So, welcome back guys to episode 3 of Digital Logic Sim. So, I think today we're going to try and make an alu, because everyone likes making that. It's quite popular. So I think first we need to make an adder, which is really simple. You just put that, and then an XOR, and an XOR. These two XORs will basically just, the first one finds if one of these one. The other one finds if it's other than that one, so it could be, it's just showing if it's odd. And then we can put an and here to see if one of those is on, and this. We'll try to do that again, and we can find out if both the top ones are on. Then from this we can do an XOR, or actually mean an OR, to connect them. And as you see, the top input turns on. 1 and 2 it's the bottom, and 3 it's both. So that's good. I can save this as a adder. Why would I think that's gonna work? It's pretty bad. Yeah, it just adds numbers. That's how it works. So then you get 4 at the top, 4 at the bottom, and put 1 more, and then connect those to the adders. A bit in a weird way also. There's 4 outputs at the end. And then, so this adder, we're going to have loads of adders. And the carry input is basically really simple. It just is here and it starts from the bottom. Then we add the ones with the other ones, the 2s with the other 2s. It's a bit fidgety, yeah. Then you get the 4s with the other 4s, and finally the 8s with the other 8s. That goes there. That goes there. That goes there. And that goes there. So we can test this. So this is a number 6. 6 plus 0, 6. That's normal. And 6 plus, I mean, that was actually 10, very sorry about that, dumb. Yeah, that's 16, and then we can add 1, and that all works, and we can do that. Well, that doesn't really do anything, so, so we've got, that, what's that? I expect, actually, let me be honest. Looks like it makes sense. I think it's a 4-bit adder. I think I've got an adder switch video where I made a 1-bit, 2-bit, 3-bit and 4-bit and connected them all up to a switch with certain inputs. Maybe you could like make a flip-flop out of that. So 4-bit adder here. So how are we going to add subtraction? Well, we don't really need this carry input. It can get a bit confusing as well. But then the carry input will change for the end, so I don't really know how it works. So we've got the carry input down there, and got these 4, which can all connect to the 4-bit adder, even though we like these subtracting. So you can then do this by putting an XOR, meaning if only that is on. So basically when we've got none on and we've got the subtractor on, then it will just subtract those knotted. Then you can make it different values. When it goes higher, it goes lower, so we're not adding as much, so we're adding even more, so then it looks like we are subtracting, but then it messes up with the carry input. So it is a bit weird, but it's how it works. So we can try adding, this time this is 6, 6 plus, well, 9 is 15. And if we want to subtract, this is 12. 12 minus 1 is in fact that. And it's positive. This just means it's positive. So we can then have 2 more inputs, show different stuff. Basically, this one will show if it's 16. So this has to have a not here and an and on top, meaning this is a HXOR. And then with that, you can put that to the top input. This should show if it's carrying the input. So we've got this, then we can add that. Yeah, it's carrying. And if we minus that from that, yeah, it doesn't work. So that's good. We got positive and negative. So when it's positive, we'll have to do a and this. So basically, they'll go there, and then we can get a BXOR, find out when this is actually, so we don't, when this is off, then it's negative, right? So if we've got 6 minus that, yeah, that shows that it's negative, meaning that we don't want that on, as you see, so then that will not bring the top, so we can put a BXOR. Can let that all up, and that can go to the bottom. So here's how it works. Got 2 8s, making this 16. That's carry input on. That's 17. Yeah. And then we can minus 2 from 8, and then you get 6. And it says it's positive, and you can minus. Well, you can do 4 minus 5 to get negative 1, it shows us that, and that's negative 8's place. Yeah. So that's just minus 8 plus that 15, and minus 16 plus that 15 is negative 1. So this is a good ALU. So now we've made an ALU. And I think you can carry on with this stuff because you've got 4-bit registers to register the inputs for in the ALU, which will be a little fun thing to do. Plus we don't have to have a register for controlling the mode of the ALU. That can just add its own little thing. Then we can have a save, and 1, 2, 3, 4, 5, 6, 7, and 8. Right. Then here it will go like that. And the save will do that much. It's a bit. Yeah, it is right now. It's like 9 o'clock in the morning or something. Here. So then we've saved things. I think it's at the top or the bottom. Good, it's at the top. So then 1, 2, 3, 4, 5, 6, 7. Connect. And yeah, that's the saving ALU, so we can save 6 plus 1, and then we get that. So then, yeah, that's how it works. So bye.